Hello, ladies and gentlemen. Today we are going to continue working with I. We're going to take a look at a couple different things today, though. What about taking I to a power, as well as dividing those complex numbers using those imaginary parts, okay? So we already added complex numbers, multiplied them, subtracted them, talked about simplifying using an imaginary number, but now it's time to take a look at that dividing and simplifying with powers of I. So for our notes today, you're going to need your notebook as well as possibly a calculator and something to write with. So let's first talk about raising I to an integer power. So what would I to the 0 power be? Well, remember, anything to the 0 power is actually 1. Well, what about if it's just I to the first power? What would that be? Well, that would be I, right? No big deal. I to the first power would be I. Well, what about I squared? Well, we learned that I squared is in fact -1. And what about I to the third power? I to the third power, a little bit different. Let me develop this for you a little bit. I to the third power would be the same thing as I squared times an extra I, right? That's how you get I to the third power. Two of them plus another one here would make I, three I's being multiplied together. I squared is -1, so this then becomes -1I, or you could just say -I. So what about I to the fourth power, and so on? Well, I to the fourth power would be I squared times another I squared. I squared is -1 times another -1. So -1 times -1 makes 1. Now notice that we're back to this repeating pattern up here, that we got back to the number 1. I to the 0 was also 1. What about I to the fifth? Well, let's do the same thing. I to the fifth would be I to the fourth plus one more I, right? Or you could do I squared, another I squared, and another I. That makes I to the fifth. So that would be -1 times -1 times I. So that would be 1I. Now look at where we were when we developed these first three. Okay, or actually first four terms. I to the third power is where we stopped. Notice that it went 1I, -1, -I. And now I to the fourth looks like it's going to start repeating that pattern again. 1I. Can you imagine what I to the sixth would be? -1. I to the seventh, -I. Okay, so we're going to repeat that pattern every four terms. So when raising I to any integer power, the answer is always 1, I, -1, or -I. Okay? That's a key deal. Then it's never going to be anything else based on the way I works, and of course the fact that I squared is -1, and so on. We will always know the answer will be one of these four options. But how will we know which one? Okay, write this part down. Another way to think about the process of simplifying I powers of I, or I to an exponent, is to divide the exponent by 4, because we saw that it repeated every fourth term. We went back to the beginning of the pattern. So if the remainder is 0, then the answer is 1. If the remainder is 1, then the answer is I. If the remainder is 2, then it'd be the same thing as what happens with I squared, or -1. If the remainder is 3, it'd be the same thing that happens with I to the third, with the remainder being 3, we'll end up with -I. So here are the four options, and it's all about dividing and thinking about what remainder we would have when we divide by 4, okay? So let's take a look at a few examples of how this works. Remember, I need to make sure you have in your notes that the remainder is 0, it's a 1. Okay, if the remainder is 1, it's an I. If the remainder is 2, it's an I squared. And if the remainder is 3, it's a -I. Okay, so let's go ahead and take a look at a few examples that use this. What about I to the fifth? Well, if we took 5 divided by 4, we'd get 1 and a remainder of 1, okay? 5 divided by 4, we get one group of 4, but we'd also have a remainder of 1. So because the remainder is 1, I know that this answer is I. Okay, the remainder is 1, therefore the answer has to be I. What about I to the 23rd? Well, let me think. If I divide that by 4, I could get down to where I to the 20th, I'd have 3 left over, right? I'd end up with 3 left over. 23 divided by 4 would be 5, and 3 left over, or a remainder of 3. That means my I, negative I, would be the answer according to this pattern. Okay? What about this business right here? Woo, notice that negative 3 in front? Don't worry about that. That's a coefficient. What we're trying to simplify is this piece. The only part that has the power is 56. So what would we get if we divide 56 by 4? Can you think of that? 56 divided by 4? Find out what we would get there, and then see if you can simplify that one, and we'll talk about that one in your notes, okay? Now let's go ahead and go into dividing complex numbers. So for this, we of course need to write this in our notes as well. Oh, this should be a funny pencil. Oh, let's draw one. Okay, write the pencil. There it is. You're writing this, okay? You are about to divide complex numbers, ladies and gentlemen. To divide complex numbers, we must do multiplying by the conjugate, what's called the conjugate, okay? So let's run through these steps here. Take a minute and write them down, and then we'll do a few examples, and then we're done. So to divide complex numbers, you must multiply both the numerator and the denominator by this thing called the conjugate. To find the conjugate, you just change the sign between the two terms in the denominator. We'll distribute using our distributive property. We'll simplify any powers of i's that we get. Remember that I squared is -1. And then we'll, of course, combine any like terms to come up with an imaginary number or a complex number in this form, okay? So our final answer is going to look something like this. Now let's take a look at what this looks like in a couple examples. Here's example 1. We have to take 3 divided by the complex number 4 plus I. It's a complex number because it's got a real number part and an imaginary number part. You can't divide by I traditionally here. We need to do something that's called using the conjugate to simplify the expression. Now the conjugate is the same expression that's in the denominator, except you change the sign in between. So instead of 4 plus I will now have 4 minus I. And I'm going to multiply the top and bottom, the numerator and denominator, by this same thing. Now 4 minus I over 4 minus I is just a fancy form of 1. We're not changing the fraction's value, we're just simplifying it in a way that gets that I out of the denominator. Just like you can't have a square root in the denominator, you shouldn't have i's there either, okay? So let's go ahead now. We're going to multiply both the top and bottom by this conjugate. So we'll take 3 times 4 and get 12. We'll also take the number 3 times the negative I, leaving me with negative 3I. Let's do the bottom. Now this is 2 things times 2 things. This is going to be a little bit more intense here. 2 terms times 2 terms. So 4 times 4 is 16. What about the 4 times the I in the back here? That's negative 4I. Now if I take the I here times the 4 in front, I get positive 4I. And I times negative I gives me negative I squared. Now notice what happens with these i's. They will cancel out because negative 4I plus 4I, when you combine like terms, we end up with no i's. Remember, I squared is the same thing as -1. So this is really saying I have 16 minus, then all of this becomes -1. 16 minus a -1 is really 17, okay? You add here because we have 2 negatives, they make a positive. So I have now simplified the expression here. I don't have any i's in the denominator anymore, and I used a conjugate of what was in the denominator to make that happen. Multiply the top and bottom by the conjugate. Let's take a look at another example here. This is our last one. Now notice what's in the denominator is what I'm going to make the conjugate of. So in my denominator I have -3 plus 6I. That means my conjugate is -3 minus 6I. I change the sign in between the real part and the imaginary part, but I don't change everybody's sign, okay? So I'm going to multiply the top and bottom of this expression times the same thing, okay? This was my original. I'm going to multiply the top and bottom by -3 minus 6I. So here we go. I'm going to multiply across the top. So if I take 2 times -3, I get -6. If I take the 2 times -6I, I get -12I. Now I'm going to do the negative I here times -3 is positive 3I. Negative I times negative 6I is positive 6I squared. Let's do the same thing with the denominator down on the bottom, or should we simplify the top? Let's simplify the top of this one first, okay? So let's do the top of this one. Let's see. Look at my i's here. I can combine those together. That would make me negative 9I. And remember, I squared is the same thing as negative 1. So this is 6 times negative 1. That's negative 6. So I would have negative 6 minus 9I minus 6 more, leaving me with negative 12 for the real number part minus 9I. Okay, now let's do the bottom. Here we go. Denominator time. Negative 3 times negative 3, positive 9. Negative 3 times negative 6I, positive 18I. Now let's do the other 6I times negative 3, negative 18I. And 6I times negative 6I is negative 36I squared. So once again, let's combine any like terms we have. Notice we have 18I and negative 18I. They'll make 0, right? And another I squared here. That's the same thing as a negative 1. So this is negative 36 times negative 1. So this would become 9 plus 36, because negative 36 times negative 1 would be positive. And now if I add those two together, I would go ahead and get 45 on the denominator, okay? So this is my simplified version of this expression, but you can't have I or imaginary parts in the denominators of fractions, all right? So we had to get rid of that, or we had to divide that out, and this is what we got. I want to thank you, ladies and gentlemen, for taking good notes today. Two big things we got. How do I make a power of I? And also, how do I use the conjugate to divide those expressions? I want to thank you for taking good notes. Kincaid out.